Good morning, fourth graders. Miss Knight here with another multiplication lesson for the week, and we're working on double-digit algorithm for multiplication. We are working on the same learning target today for the second lesson. We're still going to use equations and rectangular arrays. Let's take a look at a story problem of planting carrots. I'm planting my garden for carrots. True story. I have an area in my garden that's 28 inches long by 8 inches wide. If I plant carrots every square inch of that space, how many carrot seeds will I need for planting? So take a moment for yourself and estimate the answer for 28 times 8. Let's sketch and label the dimensions first, just like our first lesson, and it's going to be a rectangle to show the whole product with our dimensions of 8 and 28. We are going to draw a line with our two partial products. Do that now on your paper. And let's go ahead and find the products inside of that area. We know that 8 times 20 is 8 times 2 times 10. So 8 times 2 is 16, times 10 is 160, and 8 times 8 is 64. We have those two areas right here inside of our rectangle. When we look at this partial products algorithm, we look at these two parts of the array, but today we're going to look at something different, and we're going to look at the algorithm for multiplication today. We are going to multiply the ones digits first. So we are going to multiply 8 times 8 first. 8 times 8 we know already is 64. We're going to put 4 ones down here and carry the 6 tens up here. So 8 times 8 is 64. The 6 right here is in the tens place, making it 60. Now we're going to multiply 8 times 2. 8 times 2, remember, is 16. And we're going to add that 6. And 16 plus 6 is 22. Or you can think of it as 8 times 20 is 160. Plus 60 is 220. Making that a total number of carrots of 224 carrots that I need. Look at the connection to this algorithm. 220 tens, 16 tens right here, 6 tens right here, for a total of 22 tens. Look where this 4 ones comes from. So there's the first algorithm for multiplication. Let's look at another one, holding hands. There are 48 people creating a mural with one handprint each. How many fingers are included in the painting? First, just like any problem, I want you to estimate the answer for 48 times 5 first to make sure our answer is in the ballpark of what we need it to be. We're going to follow those same steps and sketch the array first and label our dimensions of 48 and 5, separating those tens out to show two partial products. And then we're going to write the products inside of the array, so 5 times 40 being 200, because 5 times 4 is 20, times 10 is 200, and 8 times 5 is 40. So if we were to look at this partial products algorithm, we know that 200 plus 40 is a total of 240 fingers. So we know that, but we're not going to stop there today. We're going to do 48 times 5. I want you to pause it and work this problem out first before I show you my steps for solving this. Now let's look at this 8 times 5 first. 8 times 5 is 40, so we put the 0 ones here and the 4 tens up here. And then we do 5 times 4, which is 20, plus 4 is 24. Or, another way to think of it, is 5 times 40 is 200, right? Plus 40 is 240. So we know that there are 240 fingers in the mural. One more story problem for today. We're looking at baseball cards. There's 144 pages in my book that holds 9 baseball cards on each page. How many baseball cards can fit inside of my book? And then we're going to estimate that answer of the product of 144 times 9 for this rectangle. And this time there's going to be 3 partial products, right? We're going to have this 9 ones over here, but we're going to put 100 and then 40 and 4. So there's going to be 3 partial products, 3 friendly numbers to multiply inside of this array. 9 times 100 is 100. 9 times 40 is 360 because 9 times 4 is 36, times 10 is 360, And then 9 times 4 is 36. Take a look at the partial products algorithm, and we know that we're going to add 900 and 360 and 36 to have a total of 1,296 cards. But we're not going to stop there today, are we? We're going to pause the video right here and work through the algorithm for what you're remembering the steps to be. So multiply that 9 times 4 first, so putting 6 ones here and 3 tens up here, right? 9 times 4 is 36. And then we're going to do 9 times 4 is 36 again, but we have to add those 3 tens. So 36 plus 3 is 39, or 390. And so we carry that 3 again. That 300 is going to be carried up. So 9 times 1, or 9 times 100 is 9, or 900 plus 3 is 12. So we have a total of 1,296 cards. Whatever you do when you multiply, just think before you multiply. Remember, the algorithm is just one strategy. Sometimes it is the most efficient, and other times we just want to multiply by 10, or we want to use an estimate, or we want to use a double half. So just think before you multiply, and thanks for working with me today, 4th graders. Best of luck on your multiplication.